All right, let's go.
Okay, hi guys. Today we're going to go over the review questions for Calculus 2 for the first midterm. So I'm going to wait a little bit so more people can join in. And in the meantime, we're going to talk about the questions that we're going to go over. So on the first page, you can see here, question 1 is going to be about finding the area under curves. And then we have subparts, sub-questions about finding the volume of solids of rotation. And then questions C and D are basically the same. It's about solids of revolution. And then question 2 is about finding the area between two graphs. Then question 3 is going to be about finding the work to pump all of the water out of a tank. And question 4 is about the average value of a function. Question 5 is about determining if the improper integral is convergent or divergent. And then question 6 is going to be about the comparison test. Question 7 is the arc length. Then question 8 is calculating the hydrostatic force of a shape under the water. And the last question is going to be about the centroid, finding the centroid of a graph or a function. Yeah, the recording will be posted on Discord. So I have divided this whole review session into 2 separate sessions. Today, hopefully we will finish page 1, and then the next workshop on Tuesday at 7 p.m. we're gonna finish the second page. So are you guys ready to go? This workshop will take about 90 minutes. Yeah, about 90 minutes if there are questions at the end. If not, then we might finish sooner. Okay, so let's get started. So here's the first question. Consider the region R in the xy plane under the graph of x squared plus 6x plus 1 above the line y is equal to 2x plus 4. So our task is to find the area of the region R. And I'm going to give you guys 3 minutes for this one.
Recording.
Okay, 3 minutes is over. Do you guys need more time? Yeah, some more time. I'll give you 2 more minutes. Okay, so 2 minutes is over. We're gonna go over the solution. So as you can see, if we put the graphs together, like this graph and this one, then this is what you should have. And the first step is we need to find the intersections. So we need to find where the graphs are intersecting, and that's pretty easy. So you just set both functions equal to each other. So negative x squared plus 6x plus 1 is equal to 2x plus 4. Then you can bring all of this to the left side. So negative x squared plus 6x plus 1 minus 2x minus 4 is equal to 0. Then this gives you negative x squared plus 4x minus 3 is equal to 0. And if you guys have any question, please feel free to turn on your mic and ask me. So we get x squared minus 4x plus 3 is equal to 0. And then we get x minus 3 times x minus 1 is equal to 0. So x is equal to 1 and 3. So that's how you get the intersections. You know that they're going to intersect at these points. Okay, are there any questions so far? So the next step is we are going to find the area under this curve. And can I erase this? Have you guys finished copying this down? Can I erase this?
Yeah.
Yeah. So the formula to find the area under two curves is a is equal to the integral from a to b. We have f of x minus g of x dx, where f of x is the top function. So that's going to be the yellow function, and g of x is going to be the function at the bottom. So let's rewrite this. We get the integral from 1 to 3 from here to here. And then the top function is the yellow function. So negative x squared plus 6x plus 1 Then we minus the lower function. That's going to be the pink one. 2x plus 4 dx. That's equal to, let's write over here, the integral from 1 to 3, negative x squared plus 6x plus 1 minus 2x minus 4 dx. So we take 6x, we minus 2x, and then 1 minus 4. So four x minus 3. And then all we have to do is evaluate this integral. So this one is pretty easy to do. So I'm just going to give you the answer, and that should be 4 over 3. And that is the area under the curve. Are there any questions? If you guys want me to go over this integral, then I can do it here. Yeah, I see one question in the chat. I'm good. Okay, it looks like you guys are good. Do you guys need more time to copy this down? All right, seems like no one has any questions. Okay, I see. Okay, in the chat. Yeah, you guys are good to go. Let's move on to the next question then. So this is question number 2. And that comes from this one here. So if a solid S has the base and the cross sections perpendicular to the x-axis or equilateral triangles, we need to find the volume of the solid. And since this one is a little bit harder, I'm going to give you guys 4 minutes for this. Yeah, I see one question in the chat. It says, what does it mean by the x-axis are equilateral triangles? Don't worry, I'll explain what it means. Okay, so 4 minutes is over. Let's go over the solution. So I remember there's a question in the chat that asks what the x-axis are equal triangles. What does this mean? So if we draw the graph, it says that consider the region R in the xy plane under the graph, this one, and above the line here. So the solid S has R as the base, and the cross sections perpendicular to the x-axis are equilateral triangles, and we have to find the volume of the solid. This means that when you draw the two graphs, so the two functions that we just did in the previous question, if we draw it, then there will be equilateral triangles sticking out of it. So you see that's a triangle, and it's gonna go from here to here. So as we go from the left to the right, the triangle gets bigger, it gets bigger, it gets bigger, and then here it starts to get smaller, and it starts to get smaller. So once you do that, it's like a deck of cards you put together, and that is going to form a three-dimensional solid. So this is a three-dimensional object. So you see the blue region here, that's the area between these two curves, that's the R region, and the S is a solid. So S is the three-dimensional object that we have to find the volume of. So let's go over this one. Now, remember the volume formula is equal to the integral from A to B. In this case, what's A and what's B? Well, we found out that the intersections are 1 and 3. So A will be 1 and B is 3 of A of x dx. So that's the formula you need to use. Now pay attention, it says this is the equilateral triangle. So the triangle sticking out like this is an equilateral triangle. So let's draw it. We have here is the equilateral triangle, which means that these two sides are 60 degrees. This one is 60 degrees as well. But instead of doing 60, I'm just gonna divide it in half like this, and then we can say that this is 30 degrees. And then this one is also 30 degrees. So if you remember from high school, the ratio of an equilateral triangle is this. It's 2, 1, and the square root of 3, right? That's the ratio of this triangle. Oh, I see one question in the chat. It says, what does the cross section mean? Okay. A cross section is very simple. So let's say that you have a piece of bread. Let's say we have a piece of bread that you buy from the market. So you want to find the volume of this piece of bread. And the way to do it is you take a knife. So we have a knife like this. And we cut it right there. So when you cut it, and then you open it, you see that the bread is gonna look something like this in the inside, right? So this piece is called a cross section. Does that make sense? Okay, that's good. You understand it. So I'm gonna erase this. On the exam, like you don't have to worry about what a cross section means. You just use this formula and you'll always get the answer. So the area is the area of this triangle because the cross section is a triangle. So the area is the area of this triangle, which means that the area, or A of x, is equal to 1/2 times the base times the height. That is the area of a triangle. Base times the height. So how do we find the base and how do we find the height? Well, it's very easy. So from here to here, what is that distance? That is the base, right guys? That is the base. And the base is equal to the distance from the top function and the bottom function. that gives you this distance. So the base is equal to 2x plus, no, actually, it's equal to negative x squared plus 6x plus 1. That is the yellow function minus 2x plus 4. Does that make sense? This is a very important step. If you don't understand, please let me know. Okay, seems like you guys understand it. So we can keep on going. Negative x squared plus 6x plus 1 minus 2x minus 4. Negative x squared plus 4x minus 3. So that is the base. That's the base, and that's the distance from here to here. That is the base. Okay, so I'm gonna draw like this. This whole thing right here is negative x squared plus 4x plus 3.
It should be minus 3.
Oh, thank you. Yeah, minus 3. Now, how do we find the height? The height is this one. That's the height. What we can do is use the ratios. Remember the ratio 2, 1, and square root of 3? Let me show you how to do that. So we have this as the base. So what is this one right here? This one. We want to take this side, and this side is going to be negative x squared plus 4x minus 3 divided by 2, right? Because that's half of the orange one. We want to take this side right here, and that's half of this side. So that has to be negative 2x squared plus 4x minus 3 divided by 2. Oh, I see one question in the chat. Would the height just be that multiplied by the square root of 3? Yes, that's correct. But I'm gonna show all of my steps so you guys can understand. We're gonna take this side, which is 1. The ratio is 1 over the square root of 3. And that is equal to, this one. Minus 3 divided by 2. And the height, we can say h. H is the height, right? So divided by the height. So you will find that the height is equal to the square root of 3 times negative x squared plus 4x minus 3 divided by 2. Does that make sense? So this height right here, I'm going to write it below. That is the same as square root of 3 divided by 2 times negative x squared plus 4x minus 3. Okay, so we're ready. We're ready to solve this integral. So the area is equal to 1 over 2 times the base times the height. 1 over 2 times the base. The base is negative x squared plus 4x minus 3 times the height. The height is square root of 3 divided by 2 times negative x squared plus 4x minus 3. That's the same as the square root of 3 over 4 times negative x squared plus 4x minus 3 to the power of 2. And then we can take out the minus 1. Square root of 3 divided by 4 times negative 1 times x squared minus 4x plus 3. This is equal to the square root of 3 over 4 times x squared minus 4x plus 3 to the power of 2. Okay, so good so far? Can I erase up here so I can have more space? Okay. Oh, I see one question. It says, where does the negative go? Do you mean this negative? Where does this one go? Is that what you're saying? Yeah. Okay, it's very simple. So you see here, we factor out the -1. We factor it out. So we get -1 times x squared minus 4x plus 3. Is that better? Yeah. So -1 to the power of 2 is 1. So you square it. And then it just disappears. Yep. Okay, seems like you guys get it. Okay. I see there are 2 more questions in the chat. Is there, it's not there. How do we expand to integrate, or is there a simpler way? Wait, do we expand it to integrate, or is there a simpler way? This is the simplest way. This is the simplest way. In fact, I think it's the only way. Yeah, it's the only way to solve this problem. So we're ready. We found the area, and all we have to do is just put it into the integral. And actually, before I do that, let's expand this. We have to expand that. X squared minus 4x plus 3 to the power of 2. Okay, that's the same as this multiplied by the same thing. That's the same as x to the power of 4 minus 4x to the power of 3 plus 3x squared. Minus 4x to the power of 3 plus 16x squared minus 12x plus 3x squared minus 12x plus 9. Let me double check to see if this is correct. It's 4, x3. Yeah, and this is, yeah, that looks correct. And once you simplify it, you're just gonna get x to the power of 4 minus 8x to the power of 3 plus 22x to the power of 2 minus 24x plus 9. So after you simplify it, that's what you should get. Are there any questions? Okay, perfect. So we just finished expanding this, and we can just plug that into our integral. We get the square root of 3 over 4 times x to the power of 4 minus 8x to the power of 3 plus 22 x to the power of 2. My pen is going crazy. Minus 24x plus 9 dx. Let's see. Now the last step is to just solve this integral, just evaluate it. We bring the square root of 3/4 out because it's just a constant, we can bring it out. Okay. So this integral right here is pretty easy to do. And I'm going to spend time to go over the harder integrals later on in the question. So is it fine if I just give you guys the answer? I'm going to save you some work. And that is the answer. That's the final answer you guys should get. And this answer is from this integral. And that's also the volume of this three-dimensional object. Now I'm going to give you guys the floor for questions. Okay, no questions. Okay, let's move on to, oh, I see one question. Have you ever tried finding the height with Pythagoras? It's much more. With Pythagoras, like I mean, you could do it, but if there's an easier way, then just stick with the easier way. For me, I like using the ratios more, but using the Pythagorean theorem would still work. So yeah. Okay, we're gonna move on to question number 3. So that question is this one. And it says, consider the region R in the XY plane under the graph, these graphs. So it's the same one that we've been doing, or we're gonna still use the same ones. And the question says, a solid S is obtained by revolving R around the line Y is equal to 10. And we have to find the volume of the solid of revolution after we rotated the area, right? I'm gonna give you guys 4 minutes for this one. Okay, 4 minutes is over. Let's go over the solution. So we have these two functions that we always used in the previous question. So when we draw them, they're gonna look like this. And so the question says we need to revolve the area R, and R is basically the area here. So that is the area R. And we have to revolve it around the line y is equal to 10. So this is the line y equal to 10. And when we rotate around it, you will get something like this. Don't you agree? Okay. So this is our three-dimensional solid. And to find the volume of this is equal to the volume of the outer function minus the volume of the inner function. So before I move on, I just want to make sure that you guys understand this. If you have any question, please feel free to turn on your mic.
Just really quickly, would this have to use the cylinder method that we learned, or like the ring method? Sorry, the ring method, ring washer.
Yeah.
Would we have to do?
Yeah.
Okay, cool. Yeah.
Actually, we can use a simpler method. It's just a cross section. You can just use cross section for this one instead of using like the cylindrical shell method or something like that. So I'll show you guys the way to do it. The volume is equal to the volume of the outside function minus the volume of the inside function. So this is the volume of the outside function, that's the volume of the inside function. And this is equal to the integral from 1 to 3, because that's from 1 to 3, right? And then we have the area of the outer function in terms of x minus the integral from 1 to 3 of the area of the inner function dx. So let me show you how to find the area for A out and A in. So the cross section, what is the cross section of this? What do you think is the cross section of both of these like solids? Is it going to be a rectangle or a circle? It's going to be a circle, that's right. The cross section is going to be a circle. So what is the area of a circle? Well, the area of a circle is pi times the radius to the power of 2. So all we have to do is just find the radius and put it into the area. Let's see, from here to here is 10, right? The distance is 10 because we're saying that the line here is 10. So the distance from here to here is 10. We picked that this is the cross section. We chose this to be our cross section. So the distance from here to here is x. The distance from here to here is y. Does that make sense? Okay, that's pretty important too. And finally, the radius would just be from here to here. It would just be from here to here. So what is that radius? What is that radius? Well, we know here is 10. We know this is y. So the radius has to be 10 minus y, wouldn't it be? Right? The radius is just 10 minus y. Yeah, you're right. So it's 10 minus y. So the area, let's find the area of the outer function first. That's equal to pi times 10 minus y to the power of 2. Okay, instead of writing the area, I'm going to write it a of x, ax out, because it's more accurate. So a x out, that's equal to pi times 100. minus 2y plus y squared. Okay. Actually, before we do that, I mean, that step is fine, but there's a better way. There's a better way. Since this function is in terms of x, we need to convert it to x first. You see, this is y, right? But we want it to be in terms of x. So this function of the pink one is y is equal to 2x plus 4, which means y minus 4 is equal to 2x, which means x is equal to 1/2 times y minus 4. Let me see the questions in the chat. Oh yeah, you're right. You're absolutely right. I don't have to solve for x. I just got confused myself there. You can just minus 2x plus 4. Yeah, sorry about that.
Wouldn't
Okay.
it stay -6? Because you didn't divide it by 2. It's like pi minus 2x plus 6, and then -1, 2x minus 3.
Yeah, you're right. Is this better? Yeah, that's right. I might have to clean up some stuff so it's easier for me to see. Because like if it's too crowded, it gets hard to see. So this is 4, right? And this is x minus 3 to the power of 2. Okay, yeah, that's correct. I know this is correct. So this is 4 times pi times x minus 3 to the power of 2. And this is the area of the outside function here. Okay, one person asked, why do we have to take out the -2? Well, I mean, like, why not, right? Because if you try to expand this, then it gets really messy, right? So if you take out the -2, then you can turn it into a 4, right? And then times x minus 3 to the power of 2, and then you can just turn it into 4 pi times x minus 3 to the power of 2. It's cleaner if you do it this way. How do we determine the inner function and the outer function? It is very simple. So if you look at this shape right here, it's very easy to tell which one is the outer function and which one is the inner function, because you can see the pink line right there, that's the outer part, right? That's the outer part, and the yellow one is the inner part. That's the inner part. Does that help? So we found the area of the outer function. It is 4 pi times x minus 3 to the power of 2. Now we're gonna find the area of the inner function. And let me clean up some space. Let's use white this time, so it's better to see. So A in X. And it's the same thing. It's going to be a circle. The distance from here to here, the distance from here to the circle is X. The distance from here to here is Y. The distance from here to here is 10. So the radius from here to here is 10 minus Y, as mentioned before. And the area of a circle is pi times the radius to the power of 2. So this means pi times 10 minus y to the power of 2. Now what is y? Y is this one right here. I circle it so it's easier to see. So y is equal to negative x squared plus 6x plus 1. Yeah, I see 2 questions in the chat. As the yeah. Okay, so I'm going to erase this and plug in the y. Ten plus x squared minus 6x minus 1 to the power of 2. Okay. Pi times x squared minus 6x plus 9 to the power of 2. Okay, yep, that's correct. And we get pi times x minus 3 to the power of 2 to the power of 2 again. That gives us pi times x minus 3 to the power of 4. Okay, are you guys okay with this? Do you understand why it's to the power of 4? Yeah. So you don't have to do it the way I did it. You can expand it if you want to, but for now, let's just keep it like this because it's clean. So the A in area, that is just pi times x minus 3 to the power of 4 dx. And that's it. That's how you come up with the equations. And the last step is perhaps the easiest step. It's just evaluating the integral. So I guess the hardest thing you can say about calculus 2 is that coming up with the equation is the most challenging part. But if you know how to do it, then the final step to evaluate the integral is very simple. Since 4 pi and pi are just constants, you can move it outside the integral. You get 4 pi times the integral from 1 to 3 times x minus 3 to the power of 2 dx minus pi times the integral from 1 to 3 x minus 3 to the power of 4 dx. A person asked, could this be done with the ring method? Yeah, you can do it, but I guess this way is simpler. This way is much simpler. So I'm going to save you some time because solving the integral is not the hardest part. And the answer will just be 64 over 15 times pi. Okay, are there any questions? No questions?
I was just really curious. So like,
Yes, please.
could you quickly let us know like what each side of the function should equal to? Like, sorry, like what each of the integrals should actually equal to check? Because like I got like 40 pi over 3. So I don't know where I went wrong. So I was wondering, what's the actual value for the right side integral that we get, and what's the actual value for the left side integral that we get, if you know?
Ah, okay. So you mean you're talking about the volume of the right one and the left one, right?
Yeah.
Okay. Yep. So I already solved it in my notes, and to get 64 over 15 pi. So you said you got something else, right? You got something else?
Yeah, I got
Um,
40 over 3 pi.
Okay. Perhaps we should go over this integral together. Okay, so it'll be much simpler to explain if we solve this integral together. So let me show you how this gets to 64 over 15 pi. And in order to do that, I would have to delete everything on here. So I'm going to delete this, okay? And I'm going to rewrite it. So the volume is equal to 4 times pi times the integral from 1 to 3, x minus 3 squared dx minus pi x minus 4, oh, x minus 3 to the power of 4 dx. So let's solve this one first. Actually, let's solve this one right here. Okay. We can write this as 4 pi times f3 minus f1. And I'll talk about what f means in a moment. Minus pi times g. Let's call it g. Actually, you can call it any variable you want. So g3 minus g1. So f of x, the big f of x is the integral x minus 3 to the power of 2 dx. Okay, one person asked, how is the second one to the power of 4? I already explained this. So, so we get, it was what? It was x squared minus 6x plus 9 to the power of 2, right? So you can make this as x minus 3 to the power of 2 to the power of 2. And that gives you x minus 3 to the power of 4. So if you go back in your notes a little bit, you'll see that this is the reason why it's x to the power of 4. Yeah. Now this one is very easy. So let u equal to x minus 3. So du over dx is equal to 1, which means du is equal to dx. This is equal to the integral. Here is u to the power of 2. Dx is du, so it's like this. And we get 1 over 3 times u to the power of 3 plus c is equal to 1 over 3 times x minus 3 to the power of 3 plus c. Okay, you guys get this so far? Now let's find f3 minus f1. F3 is equal to 1 over 3 times 3 minus 3 to the power of 3, okay? And when you plug in a number, the c doesn't really matter. Like it's like you can ignore the c. Or you can put it in here, it's up to you. Okay, but it's gonna cancel out in the end anyway. So f of 1 is equal to 1 over 3 times 1 minus 3 to the power of 3 plus c. So this will be 0, 0 plus c, right? Because 3 minus 3 is 0. And then this over here will be negative 2 to the power of 3 is negative 8. So negative 8 over 3 plus c. Yeah. So f3 minus f1 is 0 plus c minus negative 8 over 3 plus c. That's equal to 0 plus c plus 8 over 3 minus c. That's just 8 over 3. So you see that the c cancels out. The c is going to cancel out. So that's why I said that when you plug in the number, you don't have to write the c. You can just ignore the c because it cancels out anyway, right? So f3 minus f1 is 8 over 3. Now let's find G3 minus G1. I'll use a different color. So red, G3. Oh, actually finding Gx first. We have to find Gx first. That's the integral x minus 3 to the power of 4 dx. So let u equal to x minus 3. du over dx is equal to 1. Then du is equal to dx. So we get u to the power of 4 du, 1 over 5, u to the power of 5 plus c, 1 over 5 times x minus 3 to the power of 5 plus c. Okay. So G3 is equal to 0. It will be 0 because you're just plugging 3 in here, right? 1 over 5 times 3 minus 3 to the power of 5, that's 0. And then G1 is equal to 1 over 5 times 1 minus 3 to the power of 5. 1 over 5 times minus 2 to the power of 5. That should give you negative 32 over 5. Let's see. Yep, that is correct. That's correct. Now, what is G1 minus G3 minus G1? I mean, yeah, so G3 is 0. We determine G3 is 0. Then G1 is negative 32 over 5. So 0 minus negative 32 over 5 gives you positive 32 over 5. Okay. And now it's just grade 5 fractions. So 32 over 3 minus 32 over 5. So we're solving whatever is here. And I have my calculator here. 5 times 32 is 160. This is 160. 32 times 2, 96. That's 64 over 15, right? Can someone confirm for me? I'm pretty sure this is 64 over 15. So if you plug it back in here, that's going to be 64 over 15. And that's the answer. This is the answer right here. Okay. I'll erase this so there is absolutely no confusion. So the final answer is 64 over 15 pi. All right, let's move on to the next question. Now this one is interesting. This one's definitely gonna be on the midterm because when I took it last year, it was on the midterm. So consider the region R in the XY plane under the graph, the same ones. We have to find the volume of the solid obtained by revolving the region R about the line x is equal to -1. I'm gonna give you guys 3 minutes for this one. Yeah, so someone wants 2 more minutes. And let's do 2 more minutes. Okay, someone asked, how do you make negative x squared plus 6x plus 1 into a function based off y? That is a good question. I'll show you how to do it. Oh wait, the timer isn't starting. Okay. Oh well. Okay, 6 minutes is over. Let's go over the solution. So here, as you can see, this is the same functions we have been using before. And we want to rotate this area. So this area is called R, remember? So this is R. That's R right there. And we're going to rotate R around x minus 1. So once we rotate it, it's going to look something like this. We'll have a three-dimensional solid looking like this. So what is the outer function and what's the inner function? Well, the outer one is the red one. You see, it's the red one, and then the inner function is the yellow one. So that's why you see that the volume is equal to the volume of the outside function minus the volume of the inner function. And like last time, the volume is just equal to V out minus V in. That is the same as the integral from 1 to 3, A out minus the integral from 1 to 3, A in. The only difference here is that because the cross section is on the y-axis, you see that the cross section is on the y-axis. If we draw a circle, it's on the y-axis. Then we have to integrate with respect to y. If the cross section is on the x-axis, then we integrate with respect to x. Since it's on the y-axis, we need to integrate with respect to y. So this would be a of y dy. This is a of y dy. So that's the trick that you guys need to know. And then it's the same thing. So a out is equal to pi times the radius because it is a circle. So we reach from the origin to our cross section. The distance here to here is y. And then the distance from here to here, that's x. So what is the radius? If you guys can guess what the radius is, it's very easy. So we know that this is minus 1, right? This is minus 1. So the distance from here to here is minus 1. Or rather, the distance is 1. The distance is 1. So the radius is just x plus 1. And this is pi r squared to the power of 2. Could you draw the, okay, so there's a question in the chat. Could you draw the radius of the outer function on the top right graph? Could you draw the radius of the outer function on the top right graph? Oh, yeah. Yeah, we'll get there. You mean like, you mean this one? This one right here? We will do it in a moment. But let's finish this one first. Oh, no, not that one. Let's see. Just want to see what it looks like in 2D. Or the other, the top right. I'm not sure what you mean. Can you ask in the, like, turn on your mic and ask, please? Yeah, just take your time. I'm just gonna keep solving this. So what is x? Well, we want the function to be in terms of y, but this is x, so we have to convert it to x. I mean, convert it to y. So we know that the function is y is equal to 2x plus 4. So y is equal to 2x plus 4. So y minus 4 is equal to 2x. x is equal to 1/2 times y minus 4. You guys agree? We can also do this as 1/2 times y minus 2, if you prefer. Yeah, the recording will be posted on Discord. Can I erase this? So we found x. We found the value of x for the outer function. It's 1/2 times y minus 2. So this is equal to pi times x, which is 1/2 times y minus 2 plus 1 to the power of 2. This is equal to pi times 1/2 times y minus 1 to the power of 2. So that's it. So A out is this one. We will erase this right here and just put in pi times 1/2 times y minus 1 to the power of 2 dy. Okay, now let's find A in. I think someone asked about the A in. So I'll show you how to do it. We will draw our cross section. You can pick anywhere. It doesn't matter. So this is our cross section. It is also a circle. The distance from the origin to our cross section is y. Always remember that. That's y. And the distance from here to here is x. So A in y is equal to pi times the radius to the power of 2. The radius is x plus 1, remember? Because from here to here, the distance is 1. So the radius is x plus 1. X plus 1 to the power of 2. Our function for this one is y is equal to negative x squared plus 6x plus 1. So how do you solve it so that you get x is equal to something in terms of y? It's very simple. So I will give myself some more space. I'll write this up here. This is A in is equal to pi times x plus 1 to the power of 2. Y is equal to negative x squared plus 6x plus 1. You have to complete the square here. So y is equal to negative x squared plus 6x plus 9, right? Plus 9 minus 9 is the same thing. So plus 1. And then we group everything together. So we group this. Does this make sense? This from here to here. Make sure that this step makes sense to you before I move on. I think it's better if I write it this way. It's less confusing. If I write it as negative x squared plus 6x minus 9 plus 9. So I'm just reversing the order. And then we get negative x squared plus 6x minus 9 plus 10. And then we take this out. We take the minus sign out. So we get this. Okay. I think this is much easier to understand to you guys. Now we just complete the square. This is equal to minus x minus 3 to the power of 2 plus 10. So y minus 10 is equal to negative x minus 3 to the power of 2. Then we multiply both sides by minus 1. We get negative y plus 10 is equal to x minus 3 to the power of 2. So x minus 3 is equal to plus and minus y minus y plus 10. And instead of writing it as minus y plus 10, we can write it as 10 minus y. So finally, x is equal to plus and minus the square root of 10 minus y plus 3. Are there any questions here? Don't you, there's a question, don't you have to account for the minus 1 when finding the y as well? Or at the very end? Could you turn on your mic and ask me? I don't think I understand.
So like, you know, the axis of rotation, x equals -1. When we're solving for x, do we have to account for it? Like we put that into our calculations as well? Like, or do we just have to worry about that when we're just looking for the area when we have the y function?
Sorry, where? Where is it?
So like, you know how we solve for the x, right? When we got a function for x. So like, you know, since we're revolving it around the x-axis, so x minus 1, do we need to input that into the equation, or is that on a later part of the question? Like, could we input that -1? So like when we're trying to find the area, right? Like, right, we need to account for the axis it's rotating on. So like in the previous question, we had to add, subtract it from the original expression to find the area.
Like I heard you said x minus 1. Well, here it's x plus 1, not x minus 1.
No, like, but it's the axis, like it's obtained by revolving around the region R with the line x minus 1. So I'm wondering.
So it's revolve around x minus 1 and then what? Sorry.
So like for our calculations when we're solving for the new function, right? Would we need to incorporate that into that? Like we would need to pretty much make it plus 2 instead of plus 3. That's what I'm asking.
Where's plus 2 and plus 3? Where's that?
Like, okay. So at the very end, when you get x equals plus or minus square root of 10 minus y.
Oh, you're talking about here. Yeah.
Yeah. And because it's -1, would that have to become like 2? Because would you have to incorporate it, or is that something different?
I don't see where or how you say it becomes 2. It has to be plus 3. Like I don't see how it becomes 2. Or am I still not understanding your question?
Someone answered in the
would
chat.
you like me to go over this again?
No, I got it. So yeah,
because last time he had a 10. You had a 10 somewhere, so he's just wondering if it's the same exact, like doing the same thing as the last number.
I mean, if it works for you, then it works, right? It's really up to you how you want to do it. There are many different ways to do it, but this is my way of doing it, and I get x is equal to plus and minus the square root of 10 minus y plus 3. Okay, we're gonna erase this. Yeah, sorry if I don't understand your question. You can always send me an email and I will try my best to answer it. So we get an is equal to pi times x, right? We got x, this is your x. So let's see. Now, here we can write x is equal to 3 plus or minus the square root of 10 minus y. So which one do we choose? Do we choose the plus 1 or the minus 1? Now it's very simple. There is a way to figure this out. Yeah, I think this is actually the most important part in getting this question right. The difference between right or wrong is knowing if it's a plus or a minus sign. So here, let me explain which one to choose. You see this yellow function, right? You see this yellow function. When we rotate it, we only take here. Let me draw it out. So you see it like this, but when we rotate it, so we're taking the left one instead of the right one. I hope that makes sense, because what you're basically saying here is the function, our original function is like this. And when we found x, this point right here is 3 minus 10 minus y, right? And then this point is 3 plus 10 minus y. But when we're rotating it, we're using this point to rotate. Like we don't really use this one. So that's why x has to be the minus one, right? Does that make sense? Yeah, I see some questions in the chat. I don't understand. What don't you understand? So, yeah, okay, that's okay. I know this is the confusing part, but it's very important on the exam. So you know that the yellow function is y is equal to negative x squared plus 6x plus 1. And then we solve for x. Remember, we solve for x. We get x is equal to 3 plus or minus the square root of 10 minus y. So which one do we choose? When we are rotating this function, we're rotating it around x minus 1. If you just imagine it in your head, like when you rotate it, which point are you using? Are you using are you using this one or this one? Well, you see that you're using the left, right? And the left one is 3 minus the square root of 10 minus y. Then the right one is 3 plus 10 minus y, but we're not using that one. We're using the left one. We're accounting for the area when we rotate this point around here. See, when we rotate this point around here, we're using this one. We're not using the right one. So it has to be 3 minus the square root of 10 minus y. It has to be. Okay, is that better? Okay. Yeah, so Andrew said the point on the right is in the area. Yeah, you're right. You're absolutely you're right. That's another way to think about this. So x is 3 minus the square root of 10 minus y, and then we got to plus the 1. Don't forget the plus 1 here. Also a very easy mistake to make. And by this point, we can put it back into our integral. Okay, just double checking. Now, since we are integrating with respect to y, we are integrating from here to here, right? We're integrating from here to here. So we're not integrating from here to here. We are integrating from this point to this point. So on the y-axis, and this point is 10 and 6. I'll explain why it's 10 and 6. So the integral here is 6, that's 10. I'll explain why. So before, when we put these two together, we found out that x is equal to 1 and 3. But since we're integrating with respect to y, because the cross-section is on the y-axis, we have to integrate with respect to y. So when x is equal to 1, what is y? Well, we put 1 into here, right? So y is equal to 6. So this point is 6. When x is equal to 3, y is going to be 10. Yeah, sorry, I forgot to add that in before. So the integral is from 6 to 10. So I'm going to give you the answer for this one too. After you solve this, you're going to get 8 pi. 8 pi. Would you guys like me to go over these integrals? Or we can move on to the next question. Yep, I missed how you found 10 and 6. I just explained it. Would you like me to explain again? So here, I'll explain it again. So in the beginning, I forgot to mention this fact. I mentioned that we are integrating with respect to y. Because the cross-section is on the y-axis, we have to integrate with respect to y. So we can't use 1 and 3. We can't use 1 and 3 because we're integrating with respect to y, right? So we have to find the y values. We already know this is 1. This is 3. All right, when we find the area under the curve. Yeah, you can put 1 and 3 into the equation. So this point is 1 something. And what is this something? Well, you can just plug it in. You can just plug it into one of the equations. So let's do y is equal to 2x plus 4. Just put it in. So when x is 1, you get 6. So this is 6. When you put in the 3, you get 310. So that's how you get it. So you get 8 pi after you solve this. Okay, let's move on to the next question. Now the next question is very easy. So you just have to find the area of the region R between this graph from 2 to 4 in the interval 2 to 4. So 2 is right here, that is 4. So we just want to find the area between these two curves in between this interval. You guys want 2 minutes for this one? It's very simple. The answer for the last one was 8 pi. In the chat, 8 pi. If you would like me to go over it, I'll go over it. Okay. So time is up for this one. Let's just speed run through this one. So we want to find the area between here and here. So the first thing we want to do is find the area between 2 and 3. Find the area between 2 and 3, and then we add it to the area from 3 to 4. Does that make sense? So from here to here, the area is equal to, the top function is the yellow one. The yellow one is this one, plus 1. We minus the lower function, minus the lower function. The lower one is the red one. See this? So that's the lower function. That's going to be 2x plus 4 dx. And that's from 2 to 3. Now, how about from 3 to 4? So we have to add the two areas together. So we add, this is from 3 to 4. The top function is the pink function. So 2x plus 4 minus the lower function at the bottom is the yellow function. So that's going to be negative x squared plus 6x plus 1 dx. I'm going to make it a little bit easier to read. So we get negative x squared plus 6x plus 1 minus 2x minus 4 dx plus the integral from 3 to 4, 2x plus 4 plus x squared minus 6x minus 1 dx. We get integral from 2 to 3. This is negative x squared plus 4x minus 3 plus the second integral. So plus, this is going to be from 3 to 4, x squared minus 4x plus 3. Okay, and so this one is pretty easy to do. I'm gonna save your time, so I'm gonna give you the answer, and you should get 2 as the answer. Are there any questions? Okay, let's move on to the next one. And this one will be, I think it will be the last one to do for today. Yeah, this will be the last one. And whatever we still have, we'll cover it in the next workshop on Tuesday. So we have to calculate the work to pump oil out of this tank. So we have a tank is of the shape of a triangular cylinder lying horizontally 2 meters under the ground, as in the following figure. And then you just figure out from here. So they give you a diagram, and you just need to find the work in joules to pump the oil to the tank and out of the nozzle. And since this is the last question, I'm going to give you 5 minutes. Andrew, you asked what was the answer for the last problem. It is 2, just 2. And Saiduba, you asked, were most of the integrals, if not all, on your midterm when you took this class solvable only with U substitution and integral by parts? So you're asking like all of the integrals are using U substitution and integrals by parts? Is that what you're asking on the actual midterm? Yeah, like most of it, I find like 90% are just gonna be U substitution and integral by parts. But it is possible to get like trig substitution, because problem number 8 will use trig substitution. Okay, so let's solve it. In order to find a work, you just use this formula. So work is equal to the integral from A to B. We got density times distance times area. So here it says to use the density P, right, and G. So density is P times G. So let me explain what's going on here. You always put the x-axis on top of the shape, right? So this is the x-axis, the horizontal x-axis, then the vertical y-axis running down like this. Then we say that the positive y direction is under. So we know that the oil is filled up to 4 meters deep. So it is filled from here to here, and that's 4 meters, right? The oil is filled from here to here, which is 4 meters. Does that make sense? That part is pretty important. So we also know that the height of this shape is 5 because it says here that's 5 meters. So from here to here is 5 meters. But then it says it's filled up to 4 meters. So this means that this right here is 1. This point is 1. Now that part is pretty important. Are you guys understanding this? Yeah, that's awesome. Yeah, this is a pretty important part. So we pick a cross section. We're gonna pick this cross section. And the distance from the origin to our cross section is always y. That's something you can remember, which is just like the distance from the origin to our cross section is y. And then x is from here to here. Right, from the origin until we touch like the outer edge, that's gonna be x. So what is A and what is B? We need to bring all of the water out or the oil out from 1 to 5. For that reason, A is equal to 1 and B is equal to 5. Now, how about the distance? It's very easy. So we bring the cross section to the top of the tank, right? Let's bring it to the top. And that distance from bringing the cross section to the top is y. This is to go out of the tank. Or rather to the top of the tank. But then it also says that we need to bring it up 2 meters because this tank is underground, right? It's under the ground. So we have to +2 because it's under the ground. It's very important to notice all of the information it's saying here. And then you have to pump it out of the nozzle. And the nozzle is 1 meter, so +1. So this gives you the distance is y + 3. And now we're gonna find the area. The area, yeah, okay, one question in the chat. Wait, so why are the bounds 5 and 1? Oh, it's very easy. Okay, so we're bringing all of the water out from here to here, from here to here, right? Let me zoom in if possible. So we're bringing it from here to here. We're gonna pump all the oil there, right? And we already determined that this point is 1, this point is 5. So that means we integrate from 1 to 5, meaning that we bring each cross section from 1 to 5 out of the tank. Does that make sense, Joshua? Oh, you're asking why are the bounds 5 and 1? So you mean like, why is this 1 and 5? Okay, so you're asking why is this 1 and why is this 5? That's also very easy to understand. So the problem says that the oil is filled 4 meters. So do you agree that from here to here is 4 meters? Do you in the chat? Yeah. Then we're given the height is 5. We're given the height is 5. This means the height from here to here is 5. Since this is 4, then this has to be 1, right? This point is 1 on the y-axis. And then this point is 5 because the height is 5, right? This is 0. That's the Hello, can you hear me? Oh, it says, yeah, I think I just lag a little bit. And we're almost done. We're really close to finishing this. So the area, what is this cross section? What shape is that? Can you guys tell me in the chat what shape is this? Is that a circle or a rectangle or a square or a rhombus? What is the shape of the cross section there? No, it wouldn't be a triangle. Here, let me show you. So it's not a triangle, guys. Okay. If you are, it's a rectangle because if you stand here, and then you look down, then this is going to be a rectangle. It has to be a rectangle. It can't be a square. So it's a rectangle, guys. This is the rectangle. The area is base times the height. We're really close to finishing this integral. So what is the base and what is the height? Well, this is the base, that's the base, right? That's the base, and you see that this is x, right? This is x, which means that the base is 2x. 2 times x. All right. Let me know if you guys understand this part. The base is 2 times x. Yes, I don't see anything in the chat. Does that mean you guys understand it? Yeah, okay. And then the height is from, it's gonna be from here to here. That's the height. So we already given the height, that's 10. You know, it's here, it says that this is 10. So the height is 10. Base times the height, that's gonna be 2x times 10. 2x times 10. That gives you 20x. Okay. But since we are integrating with respect to y, we are, remember the cross-section is on the y-axis, right? You see, the cross-section is on the y-axis. It's not on the x-axis because the y-axis is going through it. So the cross-section is on the y-axis because the y-axis goes through it. So we have to integrate with respect to y, which means we have to convert this into y. Now let me show you a very easy trick to do the conversion. Yeah, there's a question, why do we not account for the triangle for the volume? Which triangle are you talking about? Is it this one? We wouldn't do that because we are pumping the water out of the we're pumping the oil, right? This is the oil. The oil is here. And the cross section of the oil is a rectangle. Yes, someone else asked, are you calculating the volume by integrating the area? Yes, we are. Yes, we are. But the reason why we are calculating the work in this case is because we're timing the density, right? Because water has weight, you know, it's getting pulled down. And if we calculate the volume and we also calculate the density, then that becomes the work. It's just a formula, guys. It's just a formula. So let me show you how to find the area here. So you see this? I'm gonna draw that triangle. I'm gonna draw this one, that triangle. We know that this is 5. We already determined this is 5. This is 0 because that's the origin. What is this point? What's that point? Well, we know that from here to here is 4, right? You guys see this? What I'm circling here, that's 4. So the distance from here to here is 4. That means the distance from here to here is 2. That means that this point is 2, right? In fact, I can write it like this. This is 2, 0. And then this is, let me erase this. This is going to be 0.05, 0.05. Right? Does that make sense? Also a very important part. So you can use what you learned in high school to find the area. The slope m is equal to 5 minus 0 over 0 minus 2. You're going to get 5 over minus 2. Okay? I'm going to erase this right here. So the formula is y is equal to mx plus b. We know that the slope is negative 5 over 2x plus b. So we're one step closer to finding the equation. Then we have 2 points. You can choose this one or this one. You can choose any point to plug it. Let's choose this one, okay? So the y is 0, then the x is 2, so we get negative 5 plus b. Then b is equal to 5. Right? Does that make sense? Okay, yeah, you understand it. That's great. And for that reason, the formula is y is equal to negative 5 over 2x plus 5. That is correct, yeah. Now we just need to find x. 5 plus, y plus 5 over 2x is equal to 5. So we found x. That's what x is. So x, if this is going to be 20 times x is 2 over 5 times 5 minus y. Okay, I'm gonna erase all of this. This is gonna be 8 times 5 minus y. And that's it. That's the area. We can plug it back in here. So the area is 8 times 5 minus y dy. And the last step is just solve this integral, and that's it. So since bg is going to be a constant, it's just a number. Like it's going to be 9,800, or it's going to be 62.5 or something. But in this case, the professor says it doesn't matter, right? They give you p and g, so it doesn't matter. We can just bring it outside. It's just a number, and this is y plus 3 times 8, 5 minus y dy. We can also bring the 8 out. Okay, now we're gonna solve this one. Y plus 3 times 5 minus y. We're gonna get 5y minus y squared plus 15 minus 3y. Now let me verify that this is the correct one. So 5y minus y squared. Yep. Okay. And this is pretty easy. So I'm going to give you the answer. That's going to be 1024 over 3 pg. But this right here is going to be the answer. And on the exam, you can stop here. Okay, they won't make you go any further than this. Okay, so that's it. That's it for today. Are there any questions?
I have a question, kind of.
Yes,
So
please.
the way I sort of did it differently, or the way the textbook described questions like this was, I was wondering if this was a correct way of doing it. So pretty much to calculate the base, you use what's it called, related triangles.
Yep.
So the way I did it was I pretty much made it so that it's a related triangle. So the ratio on the right side is 2/5. And because that's like half of the total top length, which is 4. And then the bottom is 5 minus y, which is the actual thing. So you multiply it to the other side. So the base becomes 2/5, 5 minus y. And then like, because we know the height of the actual like rectangular prism is or the triangular prism is 10. So it would be 10 multiplied by 4/5 this time, because you're multiplying by 2 to calculate the entire actual bottom length, the bottom base. And then you still get 8/5 minus y. But I'm wondering, would that cause problems normally?
No, that would never cause any problems. That would never.
Okay, awesome.
So it doesn't matter which method you use, as long as you get this. That's what is important, the final answer. The way you do it doesn't matter.
Right.
But I'm gonna tell you this. I'm gonna erase this. So my method is I determine the points of this in order to find the base. That's the reason why I was doing it, because if you know what this is, then you can find the base very easily. But your way is you used similar triangles, and you will still get the same, which is x is equal to 2/5 times 5 minus y. So it's the same, right? There is one problem in the future, in the next workshop, when we calculate hydrostatic force, and there's like a case where it doesn't work if you use this. So it's always better to use my method, which is just choose the 2 points and just find x. This way is always safe. Okay, it's safer.
Yeah, makes sense.
Let me show you. Oh, sorry. Let me just show you very quick. The case where it wouldn't work is this one. Using the similar triangles. It wouldn't work if you get a shape like this instead of this one.
Yes, but yeah, but in that scenario, you would have to refer, because of the top being a circle, you would need to refer to a different actual equation. No, I mean, is that like supposed to be like I don't want to waste any more of your time. That's gonna be my last question. But is that like a circular structure? Is it like, how do I say it? It's like trapezoidal, but like circular. I don't know if that makes sense. Like a cone type thing. But
Yeah,
like
it's like this. It's like a cone, but instead of a cone, they
Yeah.
cut it off here. They cut it off.
Yeah, that wouldn't obviously work because what's it called? That's like circular, right? But for this method, because it specifically has a face that's a triangle, you could just use related angles. But that makes sense why that would work in that situation.
Yeah, let me just add in something. This is the radius, right? So how do you find the radius, or how do you find x? In this case, this is x. That would be the total radius. So you would just do the same thing. Just pick this point, and then pick this point, then just find the slope, and then you just do the thing that I just did, and then you find x. This method works 100%. It always works.
All right. Thank you so much.
Yeah, no worries.